Hi everyone, what's up? This video is part of a series in which I discuss a Pyspark coding question for you to practice and become prepared for the next interview. In each video, I will use a Leetcode or HackerRank SQL question and solve it using Pyspark. Question for this video is displayed on the screen. Make sure to watch this video till the end, and if you find it useful, please share it with your friends. If you're new to the channel, then please push the subscribe button as it will help my channel grow. I post videos every week to help you clear your next interview. Also, if you found this video useful, then please click the like button and share it with your friends. Now, let's get started with the video. So the question is, write a solution to find the person name of the last person that can fit on the bus without exceeding the weight limit. There is a queue of people waiting to board a bus. However, the bus has a weight limit of 1000 kilograms. So there may be some people who cannot board. Note that only one person can board the bus at a given time. So let me show you the data first. So we have columns like person ID, person name, weight and turn. Here the turn column tells us when the customer or the passenger will board the bus. So here, based on the turn, Alice will board the bus first, then Alex will board, and then John Cena will board, and so on. Now the bus has a limit of 1000 kilogram weight. So once total number of people's weight is 1000 kilogram, the next person cannot board the bus. That is based on our question, right? So let's calculate the weight of first three passengers. So this is 250 plus 350, that is 600, and 600 plus 400 is 1000. So by this logic, only these three passengers will be able to board the bus and the last three won't be able to board it. So what does this mean? The last passenger to board the bus is this, John Cena. So I hope you understand the question and what we are aiming to solve here. So without wasting much time, let me show you the solution. So the main thing we have to calculate here is the accumulated weight or the increasing weight. So in order to do so, I've used a window function where I'm doing window.orderBy, and order by I'm doing on the basis of turn for each passenger. So if you look at this command, like line number 5, what I'm doing is qdf is our main df dot with column accumulated weight, which I'm calling the target column as sum of weight over window spec. Window spec is nothing but window.orderByTurn. So mostly you might have seen this statement used by rank, row number or the dense rank, but you can use this with any sort of aggregates if you have that requirement. So what it will do is, let's see one by one. For the first record, when turn is just 1, okay, the accumulated weight is nothing but the first record's weight, that is 250. Now let's focus on the next record, that is record number 2. Here now the total number of turns or total rows of turns are 2. If I arrange it in order by, and by default it is arranged in ascending order, right? So when calculating the sum of weight, both the rows weight will be considered. Basically, the result in this second record for accumulated weight, it will be 250 plus 350. That's why you see 600 here. So this is a way of calculating any increasing order of a particular column. In our case, we have to find out the increasing order of weight. So this is what we have done. Let's check out the next record as well. So in order to calculate the accumulated weight for the third record, we have to add up all the weights of all the records previous to it as well. So now turn has total 3 records and we have arranged it in ascending order. So what it will do is 250 plus 350 plus 400, which gives us 1000. I hope you understand what I'm doing here, and the importance of this accumulated weight we'll understand in the next step. So once we have received all the accumulated weights, all we have to do is our question demands us that maximum weight of the entire group of people should be less than equal to 1000, right? Because the bus's limit is 1000. So that's what I've done. I've applied a filter. Filter is accumulated weight less than equal to 1000. So as you can see in this data as well, there are only 3 records that satisfy the below condition. So this is what we have received. So now once we have got this, based on the question asks us that tell me that last passenger who is going to board the bus. Now seeing these passengers, and they are ordered based on their turns. So which passenger do you think will board the last? Let's see. So Alice is going to board first, Alex will board second, and finally John Cena will board last. So as I said before, this must be our answer. So whenever you get situations like this during interviews, it is very easy to achieve them by just ordering the main data frame, and you can order them based on the column that satisfies the requirement. Here, the turn column tells us which person is going to be the last one. So I've ordered this in descending order. That brings the John Cena record at the very top, and then I'm applying a limit. So limit of 1 will return only one record from the entire data that is being printed out. So as you can see, if I do a display here, I only get one record, that is John Cena, who is going to board the bus last when the total expected weight of the bus is 1000. I hope you understood how I have solved this. It is pretty easy question if you think about it, but when you get question like this during interviews, the one thing that you might miss out is this accumulated weight function. So I think this was a good learning if you have seen this first time, and there will be more questions coming in the future. So stay tuned and please subscribe to my channel. So that's it for this video. If you found it useful, then please share it with your friends and like the video. In the coming few weeks, I have planned many such videos on Pyspark and SQL interview questions. So stay tuned for them, and if you have not subscribed, then please press the subscribe button, and I'll see you next time.